So in this class, we shall be discussing about uh, some aspects of qualitative analysis, qualitative analysis of inorganic samples, qualitative analysis of inorganic samples. Now, this idea will be required majorly for your practicals. Practicals এর জন্যে this idea will be required. So, qualitative analysis of inorganic samples. Now, probably you know that regarding the cations, you already know that the cations, they are divided into several groups. You know the group 1 cations. Now this, what is the basis of this division? I'm coming to that. First, let me tell you the name of the cations. So group 1 cations, as you know, these are Pb2 plus, Ag plus, and Ag2 2 plus, if you remember. So these are the group 1 cations. Next, group 2, you know that group 2 cations, they are divided into group 2A and group 2B. Now, group 2A cations, if you look at the cations of group 2A, you'll find that there is Ag2 plus. Once again, there is Pb2 plus. So Pb2 plus, it is present both in group 1 as well as in group 2A. Okay. So the reason we will come to it later on. So in addition, there is Bi3 plus, bismuth 3 plus, and copper 2 plus, and cadmium 2 plus. Copper 2 plus and cadmium 2 plus. So these are in group 2A and group 2B cations. Now group 2B cations, you know that these are arsenic 3 plus, antimony 3 plus, and SN4 plus. So these are the group 2B cations. Next we come to group 3A. Now group 3A cations, you know that these are Fe3 plus, iron, chromium 3 plus, and aluminium 3 plus. So these are the group 3A cations. Group 3B cations. Group 3B cations, these are equally important. Nickel 2 plus, Mn 2 plus, Zn 2 plus, and CO2 plus. So these are the group 3B cations. Then comes group 4 cations. Group 4, you know, it's calcium 2 plus, strontium 2 plus, and barium 2 plus. And group 5, there is magnesium 2 plus. In addition, we say Na plus and K plus. So these are the cations which are, you'll be provided with these cations, and among these cations, we can perform direct test. Normally, you know that group analysis, that is the best way, not the best way, that is the most accepted way of finding out the cations. So we shall be discussing about some direct tests for some of the cations. That means you can find out these cations directly. So one by one, we shall be discussing some direct tests. So first of all, let me discuss, say, test for Pb2 plus. Test for Pb2 plus. So what should be done? So you have to check whether the sample is soluble in acid, HCl. So what should be done? Sample, you dissolve it in maybe concentrated HCl. If it does not dissolve, you boil it to dissolve, heat to dissolve. If required, boil. If required, of course. Okay, if required, you boil it. And then if it does not dissolve fully, maybe some portion is dissolved. It can so happen that some portion is dissolved. In that case, you have to cool and filter. Okay, you have to cool and filter. Why cooling is required? Because the filter paper provided will not be of very good quality. So It has to be cooled if required and filtered if it is not soluble. So this solution which is obtained, now if you dilute it slightly, dilute it, okay, and then add Ki solution, Ki solution dropwise, you'll find that there will be yellow precipitate, yellow precipitate. So this is an indicator that Pb2 plus may be present. Okay, this is an indicator that Pb2 plus can be present. Next, we come to test for Fe2 plus and Fe3 plus. See, suppose if you are provided with Fe2 plus, normally you see you should be, see the in the syllabus you have Fe3 plus. Okay, Fe3 plus, if you look at this, but suppose if you are provided with Fe2 plus, then it has to be converted to Fe3 plus. Okay, so what should be done? The sample, how will you convert it? If you heat it with an oxidizing agent, maybe nitric acid, you add concentrated nitric acid, and if required you boil it. If required, boil it, and then you can filter it. So with the filtration has to be performed after cooling. Okay, now this filtrate will contain Fe3 plus ion. This filtrate contains Fe3 plus ion. So what should be done with the filtrate? You can perform two tests. One, you can add potassium K4 FeCN6, potassium ferrocyanide solution, FeCN6, K4 FeCN6. Now if you add potassium ferrocyanide, so it will be converted to, you'll get Prussian blue. So blue coloration or precipitate, blue coloration or precipitate. You know that this is Prussian blue. You already have idea about what is the structure, etc. Prussian blue. So this Prussian blue will be formed. And if you treat this with ammonium thiocyanate, NH4SCN, ammonium thiocyanate, you will get blood red coloration. Blood red coloration. Now, in the, if your sample is mixed with CO2 plus, that means suppose if you are provided with a mixture of CO2 plus and Fe2 plus, Fe3 plus for example, you know that you'll be provided with mixtures in your exams. So if you are provided with CO2 plus and Fe3 plus, then if CO2 plus is present, if you perform similar experiment, okay, then what will happen? With ammonium thiocyanate, CO2 plus will give a intense blue coloration. Intense blue coloration. Cobalt thiocyanate complex. Okay, so that means you have to be careful when if you get this test, and if you get say a black colored solution, this blue color and blood red color, it will appear as black when you're adding ammonium thiocyanate. So if you get a mixture of these two, so naturally you won't be able to observe the blood red color. So you have to be careful in that case. Okay, so this cobalt is actually interfering. We say that cobalt is actually interfering in this test. So cobalt 2 plus, it is actually interfering in this test with ammonium thiocyanate. Done. So this is the test for Fe3 plus directly. If you don't want to perform group analysis, of course, performing the group analysis is always difficult and it takes a lot of time. So if you can apply these type of tests to have some idea which may be present, so in that case you can perform group analysis a bit faster if required, of course. So next, test for, sorry, then we'll come to test for copper 2 plus. Direct test for copper 2 plus. So what should be done? Sample plus concentrated nitric acid. Okay, sample plus concentrated nitric acid heated to dissolve, or you can add concentrated hydrochloric acid also, no problem. Okay, you heat it, filter if required, filter if required. So heating means you have to boil it. Okay, heat it to boiling. You should be careful that when you are boiling, the solution should not spill out. So you have to be careful. So it should be filtered if required, and with the filtrate, what should be done? You make the filtrate. You add 1 is to 1, 1 is to 1 ammonia, or you can add liquor ammonia, but you have to be careful. When you are adding ammonia, it should be added drop wise. Okay, it's very important. It should be added drop wise, and the dropper has to be clean, otherwise it will contaminate. So you have to clean the dropper properly. You need to know how to clean the dropper properly. Okay, so you have to add 1 is to 1 ammonia drop wise, and you'll find that upon addition of excess of this ammonia, this will become intense blue. This will become intense blue. So this is an indicator that copper 2 plus may be present. Okay, but you also need to know that this intense blue coloration can, if you perform similar test, if your sample, in addition to copper, if your sample contains nickel 2 plus, okay, if your sample contains nickel 2 plus, you will get the similar type of intense blue coloration. So you cannot confirm by this test that copper is present. You know that for copper, this intense blue coloration is due to the formation of this tetraamine complex. And if nickel is present, this coloration, this intense blue coloration, it is due to the formation of hexaamine nickel complex. So in order to confirm that it is copper, what should be done? You you need to you need to make this filtrate. First you add 1 is to 1 ammonia till neutral, but till just ammoniacal, ammoniacal. So you have to be careful, till just ammoniacal, and then you add acetic acid, followed by addition of K4FeCN6, followed by addition of K4FeCN6. So you will get chocolate brown precipitate. Chocolate brown precipitate. So you should be careful that this chocolate brown precipitate, it's not like dark chocolate, একটু লাইট দেখবে, light brown হয় কালারটা. So normally this chocolate brown precipitate, it is insoluble in acetic acid medium. So that is why the solution should be acidic with respect to acetic acid. Okay, next we shall perform the test for nickel 2 plus. Now test for nickel 2 plus. Sample, you dissolve this in concentrated HCl. Okay, if required, boil. So this solution, Ni, when you are dissolving in concentrated HCl, so what will happen? This will be converted to NiCl4 2 minus, isn't it? In presence of concentrated HCl. Now what should be done? You add 1 is to 1 ammonia or liquor ammonia, and dimethylglyoxine. So the medium has to be ammoniacal when you are adding dimethylglyoxine in order to get a, what will you get? You will get a um, you'll get a precipitate which is rose red. You'll be getting a rose red precipitate. You already know this. So this is H2DMG actually. So the rose red precipitate is of NiHDMG whole twice. So the rose red precipitate is due to this. But the medium has to be ammoniacal. Unless the medium is ammoniacal, the rose red precipitate will not be obtained. And one more thing, you'll find that a reddish to orange precipitate will be obtained if Fe2 plus is present. Okay, so Fe3 plus, sorry. Fe2 plus, Fe2 plus, Fe2 plus is present, you'll find that this will interfere in your test. So you have to be careful. The color has to be exactly rose red. If you get different colors, you should not be bothered. Okay, I mean you should not bother that. But I think you'll yeah, your inference will be nickel is not present. Nickel 2 is not present. So this is the confirmatory test for Ni2 plus. Next we shall come to another cation. So this is regarding cadmium 2 plus. আচ্ছা cadmium 2 plus পরে বলছি. If you look at chromium, how to detect the presence of chromium 3 plus and manganese 3 plus. This is by fusion test. So this is fusion test for chromium 3 plus or chromate and Mn2 plus. So for by fusion test you can determine the presence of chromium 3 plus. It can also be chromate and Mn2 plus. So how to perform the fusion test? You have to perform the fusion test in a mica foil. মানে আমি কি করছি? You actually take a mica foil. See these mica foils, they are available in the lab. Now in this mica foil you add the sample plus fusion mixture will be provided, and you take this maybe fusion mixture should be taken in excess. You take it in slight excess plus one bead of sodium hydroxide. Okay, so this entire thing it will be taken over this mica foil. So you take this entire thing in this mica foil, over this mica foil, and then you fuse it. And this will be subject to fusion. Fusion mane, you melt korcho, you are melting it. That means you take the mica foil over a Bunsen flame. So you have to use tongs to keep the mica foil, to hold the mica foil. Okay, so it should be heated fusion till it melts. You'll find that it will melt. Okay, so it should be heated. So solid state reaction করছি আমরা স্যাম্পলটা দিয়ে এটা মেল্ট করছি. দেখো if the color, see what happens if chromium is present, it is converted to chromate. So if the color is yellow, if you observe that the color is yellow, then chromium 3 plus or chromate is present. And if the color is green, if you observe green color, then Mn2 plus is present. It is converted to manganate. That means MnO4 2 minus হয়ে গেছে. So Mn2 plus is confirmed. Okay, so এই fusion টেস্টটা এইটুকুনি দেখলেই হয়ে যায়. But if you look at the fusion test, further একটু procedure আছে, সেটা তোমরা দেখে নিতে পারো. But you can confirm it by this way, by looking at the color directly. Next, so manganese-টা আমরা এইভাবে দেখতে পারি. Manganese-এ আরেকটা টেস্ট আছে. So to confirm Mn2 plus, You can also perform sodium bismuthate test. Sodium bismuthate test. This test is also a very good confirmatory test for Mn2 plus. So what should be done? Sample in 1:1 nitric acid, boil, and if required, you filter it. Okay, so with the filtrate, you have to perform the test. So what should be done? If needed, you can dilute it, or you take a small amount of filtrate in a test tube and add. You are taking this filtrate in a test tube and add a few grains. Remember, a few grains of sodium bismuthate. This is the solid. Don't add sodium bismuthate in excess, otherwise you won't be able to observe this pink color. So you should not add sodium bismuthate in excess, so that so that uh, the pink color, if you want to observe the pink color, do not add sodium bismuthate in excess. So if you have to add a few grains of sodium bismuthate. Okay, you have to add a few grains of sodium bismuthate. Follow? So, and what will happen? You will observe a pink color. একটা pink color পরিষ্কার দেখতে পাবে. This is due to formation of permanganic acid. তাহলে this is due to formation of permanganic acid, HMnO4. But as you can well understand that permanganic acid is not stable. So naturally, when you are adding, when this permanganic acid, a solution this color will not persist for long. Okay, because it is not stable. Maybe you will obtain a brown precipitate after some time, even if you are adding a few grains. So please perform this test properly. Otherwise, you won't get the pink color. Okay, so we have performed the test for manganese. Next, we shall perform test for cobalt. Direct test for cobalt. Sorry. So we shall perform the direct test for cobalt. See, for cobalt 2 plus, concentrated HCl, okay, and boiled to dissolve. If required, filter, and the filtrate will be COCl4 2 minus, right? So tetrachlorido cobaltate 2. Now this color, this will be intense blue. So if a sample, upon heating with concentrated HCl, if you get intense blue coloration, there is a possibility that cobalt 2 plus may be present. Now what should be done? There are two things. If you take a test tube filled with water, okay, filled with water, and you add just one drop of it, one drop, one or two drops, okay, one or two drops of this solution, what will happen? You will observe a pale pink color. Pale pink color. A pale pink color may be observed. Why? Because of the formation of hexa aqua cobalt 2 complex. A pale pink color may be obtained. Now, if you are unable to observe this pink color, you can perform another test. See, with this, to this solution, you add ammonia. You add first uh, ammonium bifluoride or glacial phosphoric acid, H3PO4, followed by addition of ammonium thiocyanate. Now we are adding glacial phosphoric acid to mask Fe3 plus. If Fe3 plus is present, so it will also react with ammonium thiocyanate, isn't it? So in order to mask Fe3 plus, we have added glacial phosphoric acid and followed by ammonium thiocyanate. So you will get blue color, intense blue color. Now when you are now if you get this intense blue color, maybe like this. Now to this solution you add amyl alcohol. Amyl alcohol, you add amyl alcohol and shake it. ঠিক আছে, এটাকে শেক করছো, এখানে তুমি মেবি কিছু একটা আমুল বা কিছু দিয়ে, আমুলটা দিলে you have to wear a gloves, so you shake it vigorously. So you'll find that this amyl alcohol layer, suppose this is the amyl alcohol layer. Now this amyl alcohol layer, it will turn blue. So after addition of amyl alcohol, if you shake it, this amyl alcohol layer will turn blue. That means this intense blue color যেটা দেখছো, this amyl alcohol এর মধ্যে এই intense blue কালারটা চলে আসে. So when you are adding amyl alcohol, the amyl alcohol layer will turn blue. Amyl alcohol. So you're adding amyl alcohol. So blue coloration of amyl alcohol layer. Okay, so this is how you can confirm cobalt 2 plus in solution. Then we can get some idea whether Zn2 plus is present or not. Although this is not the confirmatory test, I'm coming to this. So if you want to carry out test for Zn2 plus, if you want to carry out test for Zn2 plus, what should be done? See, this is not a confirmatory test, but this is an indicator that Zn2 plus may be present. So what should you do is sample plus NaOH, sample plus maybe concentrated NaOH. ধরো তুমি একটা you take a bead, sodium hydroxide bead, 1 NaOH bead plus say 5 to 6 ml water. See, whenever you are taking sample should always be taken a very small pinch. Don't take a large amount of sample. Always take very small pinch of sample. যে কারণে তুমি যদি বেশি sample নাও দেখো, then what will happen? You are adding small amount of water. See, you are performing the test in a test tube. So in test tube scale means very small amount. Okay, so then what you will do, you actually reflux this. You boil it. The boil করলে কি হবে? If sample contains zinc, it will be converted to sodium zincate. Okay, so it will dissolve. If it does not dissolve, you filter it. The filtrate will obviously be sodium zincate, because there can be other samples also which will not dissolve in NaOH. So that's why filtration is required. Filter. So you filter this, and the filtrate, এই যে filtrate আছে, now this filtrate is sodium zincate. Now if you add HCl or ammonium chloride, okay, you'll find that white, by if you add H2S gas, preferably if you add H2S gas, pass H2S gas, you'll find that white precipitate will be formed. So how to pass H2S gas? Remember, from Kipps apparatus, you have to, there is a tube like this. Kipps apparatus will be provided with Kipps apparatus. Okay, এবং এখানে দেখবে একটা রাবার টিউব লাগানো আছে. So what should be done? You এখানে একটা তুমি গ্লাস পাইপ ভালো করে ধুয়ে এই গ্লাস পাইপটা লাগাবে কিপস অ্যাপারেটাসে. ঠিক আছে, এই কিপস অ্যাপারেটাসে গ্লাস পাইপ লাগাবে, and use the glass pipe, যে গ্লাস পাইপটা ক্লিন করে নেবে. পুরনো গ্লাস পাইপ লাগানো থাকলে সেটা ইউজ করবে না. ঠিক আছে, একটা ক্লিন গ্লাস পাইপ নিয়ে you pass H2S gas like this through your solution. You'll find that এখান থেকে H2S gas pass যখন করছো, ঠিক আছে, white precipitate of zinc sulfide. So this is a test by which you can have some idea whether zinc is present or not. তাহলে এখানে তুমি যদি white precipitate পাও তাহলে zinc থাকার সম্ভাবনা আছে, there is a possibility that zinc may be present. Okay. Fine. So these are some of the tests, direct tests for cations. There are other tests also. So it shall be discussed in the uh, next video. Okay, so I'm stopping this video.